Welcome to The Explainer. AI. It isn't just sci-fi anymore, right? Its language is everywhere, in the news, in our apps, on the job. But what does it all actually mean? Today, we're going to cut through all that noise and give you a clear, simple guide to the terms you really need to know about artificial intelligence.
For this explainer, we're leaning on an awesome guide from Virtualization Options LLC. They're a technology research and education group based out of Colorado, and their whole thing is making super complex topics easy to get. So we've distilled their work into the key ideas you need to know.
So, what if you could do more than just hear these buzzwords? What if you could actually feel confident, reading the headlines or joining in on the conversations that are shaping our world? Well, that's exactly what we're going to do today. Let's get you fluent.
We're going to tackle this kind of like peeling an onion. First, we'll start with the big picture stuff. What even is AI? Then we'll peek inside at its building blocks and then see how it actually learns. After we see it in the wild, we'll get to the real heart of it all, the ethics and what comes next.
All right, Section 1, Demystifying Artificial Intelligence. Before we dive any deeper, we have to get on the same page about what this term really means.
So what is artificial intelligence? At its core, the mission is actually pretty simple. It's the science of making machines that can do things that would normally require a human brain. Things like problem solving or understanding what we say. It's not one single thing. It's a whole field of tools and ideas.
Okay, but here's maybe the single most important distinction you need to make. On the one hand, we have the AI that exists right now. That's artificial narrow intelligence, or ANI. It can be a genius at one specific thing, like playing a game or recognizing your face in a photo. On the other hand, you have the sci-fi dream, artificial general intelligence, AGI, a machine that can think and reason just like a human. That's still just a theory. The main takeaway? Everything you see and use today is narrow, specialized AI.
Okay, Section 2, the core building blocks. So if AI is the big picture, what are the actual engines making it all happen? Let's look under the hood.
The main engine driving everything is machine learning, or ML. And this is so cool, it completely flips the old way of programming on its head. See, instead of a person writing thousands of lines of rules, you just feed the computer a ton of data, like pictures or text, and the machine learns the patterns all by itself. It learns from experience, not instructions.
And if machine learning is the engine, you can think of deep learning as the high-performance supercharged version. It's a really powerful kind of ML that uses structures with tons and tons of layers. That's why they call it deep, and that lets it find much more complicated patterns. This is the tech behind huge breakthroughs, like understanding human speech.
So what's that deep structure made of? Well, it's made of neural networks. And these are systems that are literally inspired by the human brain. They're built from layers of these connected digital neurons that pass signals to each other, spotting patterns and learning in a way that kind of mimics how our own brains work.
Section 3, how machines actually learn. We've seen the parts, but how do you go from a blank slate to a smart, functioning AI? Let's walk through the training process.
It's really just a three-step process. And the best way to think about it is like a student cramming for an exam. Step 1, you give it the textbook, which is a massive amount of training data. Step 2, you give it a study method, which is the algorithm. And Step 3, after all that studying, you get the final product, the AI's knowledge, which is a trained model ready to go out into the world. That algorithm, the study method, is basically the recipe. It's the specific, step-by-step set of instructions that the computer follows to chew through all that data and get better at its job. This is the logic that turns all that raw info into something intelligent.
Now, there are two main study methods. On the one hand, you've got supervised learning. This is just like studying with flashcards. The data is all labeled. It has an answer key. This picture of a cat is labeled cat. So the AI learns by checking its work. On the other hand, you have unsupervised learning. This is like I just dumped a giant bin of Legos in front of you and said, sort these. There are no labels, so the AI has to find the hidden patterns all on its own.
And there's a third way too, reinforcement learning. This is just learning by trial and error. Imagine an AI playing a video game. It gets a little reward, a point, for a good move, and a penalty for a bad one. Over millions and millions of tries, it just keeps trying to maximize its score. And in doing so, it teaches itself how to win. But, and this is a really big but,
This whole learning process has a major Achilles heel. What happens if the textbook, that training data, is flawed? Well, that's how you get AI bias. If the data we feed the machine is incomplete, or if it reflects our own prejudices, the AI will learn those prejudices as if they're facts. Here's the key. An AI is only as good or as fair as the data we give it.
And this is not just some theory. The source material gives this perfect, kind of sobering example. A facial recognition AI trained predominantly on data sets from one demographic group may exhibit lower accuracy or outright fail to identify individuals from underrepresented groups. If the data is biased, the tech can fail and fail badly. It's one of the biggest problems we're facing in AI.
Section 4, AI in our world. Okay, so we've been deep in the weeds of theory. Let's pull back up and connect this stuff to the tools you're probably using every single day.
You just can't get away from the biggest buzzword out there right now, generative AI. The name says it all. It generates stuff. It creates new things. While older AI might be good at sorting or predicting, these new models can actually create brand new text, brand new music, and brand new images that have never existed before.
And the engine powering a lot of this is the large language model, or LLM. These things are just massive. They're enormous neural networks that have been trained on basically the entire internet. And because of that, they've gotten unbelievably good at understanding and generating human-like conversation. If you've ever used an advanced chatbot, you've used an LLM.
LLMs are really the latest evolution in a field called natural language processing, or NLP. You might not know the term, but you use it constantly. Your email spam filter, your phone's autocomplete, real-time translation apps, customer service bots, that's all NLP. It's the invisible AI that lets our computers understand our language.
Section 5, Ethics and the Future. Okay, this brings us to our final and maybe our most important section. We are building technology that is incredibly powerful. So, what are the rules of the road?
This is the vital field of AI ethics. And this isn't about programming. It's about principles. It's about asking the hard questions like, how do we build this stuff so that it's fair and safe? How do we prevent it from causing harm? And ultimately, how do we make sure AI actually serves humanity's best interests? Which leaves us with this final, really provocative question to chew on. We know an AI is just a reflection of the data we train it on. So, if the AI ends up being biased, who's really to blame? Is it the mirror, or is it the world that it's reflecting? That's the challenge we all have to think about as this tech becomes an even bigger part of our lives. Thanks for watching.